When the Voyager 1 swung by Jupiter in 1979, scientists got their first glimpse of lightning on the Solar System's biggest planet. The spacecraft not only snapped a photo of a lightning storm but also detected radio waves from the strikes. But the radio signals slightly differed from what researchers have recorded on Earth, raising questions about the nature of lightning on Jupiter. Now, reports Charles Q. Choi at Space.com, the Juno spacecraft has taken its own measurements and found that lightning on Jupiter is not as strange as we once thought. Previous recordings of Jupiter's lightning, dubbed whistlers thanks to their characteristic whistle-like sound, all seem to fall in the kilohertz range of the radio spectrum. Lightning on Earth booms in the mega or even gigahertz range. As Choi reports, scientists have speculated many reasons behind the difference, including variations in the atmosphere or even fundamental distinctions between how lightning forms. Many theories were offered up to explain it, but no one theory could ever get traction as the answer, says Shannon Brown, Juno scientist at NASA's Jet Propulsion Laboratory, in a press release. So to learn more about lightning on the gas giant, researchers analyzed data collected by the microwave radiometer instrument on Juno, which picks up a wide spectrum of radio frequencies. And the results came as a bit of a surprise. All 377 lightning discharges recorded in Juno's first 8 flybys struck in the Earth-like megahertz and gigahertz range. In the release, Brown explains a possible reason behind the discrepancy. "We think the reason we are the only ones who can see it is because Juno is flying closer to the lighting than ever before, and we are searching at a radio frequency that passes easily through Jupiter's ionosphere." They published their findings this week in the journal Nature. As study co-author Bill Kurth, a physicist from the University of Iowa, explains to Ryan F. Mandelbaum at Gizmodo, previous flybys orbited the planet in a ring of electrically charged particles known as the Io-plasma torus. This could have interfered with the signals. Juno, on the other hand, buzzed by the gas giant some 50 times closer than Voyager 1. Those close passes allowed scientists to discover another similarity between lightning on Jupiter and Earth, the peak rate of striking. In a separate article in the journal Nature Astronomy, researchers analyzed 1,600 Jovian lightning strikes, finding a peak rate of 4 strikes per second. This is much higher than Voyager previously detected and similar to rates found on Earth. Given the very pronounced differences in the atmospheres between Jupiter and Earth, one might say the similarities we see in their thunderstorms are rather astounding, Kurth tells Choi. But there is one big difference between lightning on Jupiter and Earth: location. The majority of Jupiter's zaps take place near the poles. Meanwhile, the bulk of lightning on Earth strikes near the equator. Jupiter lightning distribution is inside out relative to Earth, Brown says in the press release. So why are things flip-flopped? As NASA explains, it's all about the heat. Jupiter is about 25 times farther from the Sun than Earth, meaning that, unlike our planet, it gets the majority of its heat from itself. The sunlight that does reach Jupiter heats up the equatorial region, leading to an area of atmospheric stability that prevents warm air from rising. The poles, however, have no such stability. heat rising from the planet creates roiling convection currents that lead to storms and lightning. There also seems to be more lightning in Jupiter's northern hemisphere compared to its southern side. Though researchers aren't yet sure why, answers may soon be coming. NASA just re-enlisted Juno, adding another 41 months to its mission. The little craft that will continue to beam back new insights about the gas giant through 2021. Like this article? Sign up for our newsletter.